Hello everybody, welcome to our second webinar in our 3-webinar series where we're discussing the power of positioning in resources. My name is Sarah Solway, I'm GM Member Engagement at Amira Global, and Amira in partnership with Frontier SI are hosting this webinar series, and also a workshop on the 3rd of December where we're going to discuss challenges and opportunities around spatial science and in particular positioning. Last week we heard from Chris Marshall at Frontier SI. Chris spoke about the SBAS technology and the potential benefits for the resources industry. If you missed that webinar and would like to watch the recording, then you can do so by going to the Amira Global website, Power of Positioning in Resources page, and which is where you probably registered for this webinar, and you'll be able to click on the link. Everybody. My colleague Anil Subramania gave an overview of Amira in our webinar last week, so I'm not going to go through that again. I know there's a few people on this webinar that attended that one, but again, that is included in the recording from last week. There is an opportunity to ask our presenter this week questions. You can either type your question into the Q&A in the control panel, in the GoToWebinar control panel. Alternatively, if you'd like to ask a question directly, then please raise your hand, and at the end of the webinar, I'll be able to unmute you and you'll be able to ask your question in person. So I'd like to introduce you to our presenter this week. Ryan Ruddick is Director of GNSS Infrastructure and Informatics at Geoscience Australia. Ryan is leading the expansion, enhancement and modernisation of Australia's national GNSS network. And with more than 15 years of experience working with GNSS networks, he has developed an in-depth understanding of both the technical and functional aspects of GNSS and a holistic understanding of network operations. Ryan sits on the governing board of the International GNSS Service, where he represents the views of other network operators and is aiding in the development and implementation of modern data standards to improve the access and distribution of GNSS data and products. So welcome, Ryan. Thank you for your time. I'm going to pass the baton over to you now and turn off my webcam, and I will talk to you all again at the end of the presentation. Thank you, Ryan.
Okay, good afternoon for those on the East Coast, and good morning to everyone on the West. Thank you, Sarah, for the introduction, and to Frontier SI and Amira Global for the invitation to speak at the Power of Positioning and Resources webinar series. As said in the introduction, my name's Ryan, and I'm the Director of GNSS Infrastructure and Informatics at Geoscience Australia. Now, for those listening who aren't familiar with GNSS, it stands for Global Navigation Satellite Systems, and the most common GNSS is the Global Positioning System, or GPS, operated by the United States. In Australia, we're really fortunate that despite not having our own GNSS constellation, we're in a region that allows us to see and use all of the 4 global constellations. That's GPS, as I mentioned earlier, GLONASS, operated by Russia, Galileo, operated by the European Union, Beidou, operated by China, as well as the 2 regional constellations, UZSS, operated by Japan, and NAVIC, operated by India. What this means is that we're able to see and use more satellites in Australia than some of the other places around the world, and that improves the resilience and performance of positioning applications in Australia. So within Geoscience Australia, my team is responsible for the network of GNSS reference stations that stretches from the Cocos Islands in the west to the Cook Islands in the east, Micronesia in the north, down to the Australian Antarctic Territory in the south. And when I say network, this includes not just the ground-based infrastructure, I don't know why that moved, but also the digital infrastructure and systems that are used to track, verify, optimize, and deliver the data to our users. So the aim of this webinar is to introduce the Positioning Australia program and the services or offerings that we'll be providing, and discuss a little bit about how they can be used in the resource sector. So the webinar is sort of split into 4 short components. First, I'll quickly talk about positioning in the resources sector. I'll discuss the concept of precise positioning, introduce the Positioning Australia program, and then use a Q&A session at the end to talk about some future opportunities. So economic modelling has shown that the uptake of precise positioning technologies in Australia across multiple sectors will provide a benefit of around $6.2 billion over the next 30 years. And a quarter of that is projected to come from the resource sector. I will add that those numbers are a little conservative. They do come from a small number of applications and using one technology. So it's more likely to be a bit higher. But I think what it is fair to say is that the resource sector has been an early adopter of positioning technologies. Common applications can be found in exploration, monitoring, automation, and safety. And this slide shows a few examples of where positioning could be used. One example I'll point out is that weird-looking pole with some aluminium on the side of it in the top right-hand corner. That's some work we're doing at Geoscience Australia on combining satellite radar observations with GNSS to determine very small vertical movements in the land. And that's useful in determining subsidence or uplift due to mining activities, or monitoring movement of things like tailing dams. When you do look at these applications in a bit more detail, it's evident that each application requires a different level of accuracy and integrity. So an example being that a completely automated mine site requires a level of accuracy probably better than 5 centimeters, with very high levels of assurance or integrity. And these requirements cannot be achieved by standalone GNSS receivers, but require some level of augmentation or correction. So I think this is where, or what I think is augmented GNSS is really an enabling technology for things like automation, which is increasingly becoming a way of the future, not just in the mining and resource sector, but also many other industry sectors like transport and agriculture. And when we sort of look at improving automation, we're looking at improving efficiency and safety. So some of the key findings from that economic benefits analysis that relate to the resource sector were that improved positioning at mine sites will reduce vehicle collisions, improving safety, and as you can see in the text there, saving lives. Improved positioning in drilling guidance systems will see efficiencies in the order of $6 million during exploratory activities, again, improving efficiency. And that's not changing slide for some reason. There we go. Improved positioning will see an increase in 10 to 20% in overall equipment availability, again, improving operational efficiencies across the sector. Okay, so that's a little bit about the resource sector. For those in the audience who are all over precise positioning and GNSS, the next few slides won't be that exciting, but for those who know nothing about positioning, then I thought it'd be beneficial just to give you a really quick understanding of some of the technologies that we use in precise positioning. So as I said earlier, standalone GNSS equipment cannot achieve the accuracies needed for most modern industrial applications. In fact, alone GNSS equipment like that you'd find in your mobile phone or your in-car navigation system are really only good to between 5 or 10 meters. And that is excellent in helping you navigate from point A to point B or find your favorite fishing spot, but it's not accurate enough to differentiate between one side of the road or another. And when you look at sort of autonomous vehicles, You don't just want to know where you are on the road, but you want to know which lane you're in and what obstacles or vehicles are around you. So why is GNSS not that accurate? Well, it comes down to a few common errors. First of all, it's how well we know the location of the satellites. Secondly, errors in the satellite clocks. GNSS works on observing the time it takes for a signal to travel from the satellite to the receiver. So an error in the clock relates to an error in the position. And also delays as that signal travels through the atmosphere. It causes a little bit of uncertainty and error as well. One side benefit though is we can actually do the reverse and model some of the delays as the signal goes through the atmosphere, and we can actually use that to determine water in the troposphere, and that can be used for extreme weather modelling. So there's sort of a side benefit there that's quite novel. And Geoscience Australia are working with RMIT and the Bureau of Met on a project looking at that. But if we can improve those error sources, we can improve our positional accuracy, which is what we refer to as sort of augmented or corrected GNSS. An augmented GNSS is not really a new technology, although at the moment it is one that's quickly evolving as precise positioning applications become more ubiquitous in society. In fact, I'd say that specialist users with specialist equipment have really been doing sort of centimetre level positioning for well over 20 years now. It's probably a good time to just stop and talk about what I mean by precise positioning. When I talk about precise positioning, I'm talking about positioning with an accuracy better than sort of 10 centimetres. Typical users such as surveyors or control traffic farmers, or even those in the resource mining sector, really do require accuracies of better than 2 centimetres to achieve their work. So this is commonly, or has been commonly achieved through setting up a reference station over a known point or a survey mark, and then you making observations in reference to that mark. And we refer to this technology as sort of real-time kinematic or RTK positioning. So you can see in the images here, there's a tripod with a GNSS sensor set up over a known survey mark, and then there's a surveyor undertaking a detailed survey. I will flag that those two pictures are very, very far apart because I didn't have too close together. The base station there is actually set up in Tasmania, and that was on a survey we were doing looking at underkill clearance of that ship in the background. And that sort of work's going on in the resource sector a bit, picked up in sort of PIL reports where they're looking at how much iron ore they can actually put on some of the vessels to optimize the amount they can carry and still get out of the harbour. That one's down in Tasmania, as I said. The other photo with the surveyor there is actually one of our continuously operating reference stations, which I'll talk about later, over in Western Australia at Hyden near Wave Rock. So I think RTK technology is probably the most accurate way at the moment to use GNSS. The technology has evolved a bit over time, and users now don't need to actually purchase their own reference station and set up over a mark. Commercial operators and government agencies such as Geoscience Australia, or as you can see in the slide, the New South Wales state government, have set up networks of continuously operating stations that allow users to connect to those data streams over the internet. And we refer to these stations as continuously operating reference stations, or CORS. Many companies have also gone a step further and developed algorithms that allow the establishment of virtual CORS, and that ensures that the user is always close by to a reference station to optimize performance and accuracy. And I'd say that at the moment in the resource sector, most of the positioning technology is some form of RTK positioning, with larger mine sites having their own dedicated network that they control that provides high levels of assurance. And the next sort of big advancement at the moment in positioning technology is what we're calling precise point positioning. Unlike RTK, on network RTK, this technology relies on regional or local models of the satellite clocks, orbits in the atmosphere, rather than direct connections to a known reference point. This ensures that users can operate across larger areas without having to rely on dense infrastructure, and that's a lot better for mass market delivery. So this technology works by taking streams from reference stations, delivering them to a processing center, generating corrections, and then delivering them to the users. So in the webinar last week, Chris talked about the work we're doing at Geoscience Australia around, and through Frontier SI, around delivering those corrections via satellite. But they can also be delivered over the internet. And over the internet allows us to have higher bandwidth, which allows for more accurate solutions and better performance. Okay, this table really just summarizes the differences between those technologies I just talked about. The key points are that by itself, GNSS is really only good to around 5 or 10 meters. You can augment GNSS using RTK or network RTK positioning that allows positioning below sort of the 2 centimeter level, but does require high densities of ground stations. When you start looking at PPP and PPP RTK, which is a combination between the two somewhat, you can have sparser networks of ground infrastructure, cover larger regions, but there are some trade-offs in terms of how fast that accuracy or that signal converges to a fixed solution. Okay, I think now onto the Positioning Australia program. So as our tagline says, accurate and reliable positioning for everyone. So at Geoscience Australia and through our predecessor agencies, we've been operating space geodetic infrastructure for more than 50 years now. And this includes satellite laser ranging stations that we use to monitor satellite orbits, and also helps us determine the center of mass of the Earth, which is the origin of our reference frame. And next week in the third webinar in this series, Nicholas Brown from Geoscience Australia will talk about reference frames in more detail. We also operate radio telescopes that are used to position and orientate the Earth in space. And for the last 30 years, we've been operating a network of high quality GNSS reference stations that are used for used mainly for developing and maintaining our national and international reference frames, but also for a myriad of other scientific and societal applications. And in doing this, we've really established at Geoscience Australia a group of experts in position, navigation and timing, or PNT. Chris also would have mentioned the focus of Chris's webinar last week was on our satellite-based augmentation system testbed. So in about 2017, we partnered with the New Zealand government, Frontier SI and some commercial companies to test the delivery of augmented GNSS signals via satellite. That testbed was a success and led to 2 positioning related budget measures being announced in the 2018-19 federal budget. The first of these measures was aimed at improving positioning in regional Australia through a satellite-based augmentation system. And the second, which will be the focus of the rest of the webinar, was aimed at improving positioning for Australian businesses. And this is what we refer to as the National Positioning Infrastructure Capability. Together, these 2 measures form an integrated national positioning system that we now refer to as the Positioning Australia program. So SBAS will provide a service that allows down to 10 centimeter accurate positioning anywhere, anytime, including the maritime zones. And MPIC will enable centimeter accurate positioning in areas with access to mobile internet. So the mission of the program is to enable Australia to progress and thrive by providing the infrastructure for better positioning technology. And this will enhance accuracy and reliability, accelerate economic growth, and allow for the uptake of innovative technologies. Now, what I'm going to do is switch to a short video that will hopefully load that basically says all of that in a much more fun, cartoony fashion. Okay, apologies for that. What we'll do is we'll share the YouTube link later. Okay, so as I mentioned earlier, the objective of the National Positioning Infrastructure capability is to enable a 3 to 5 centimetre accurate position capability in areas with mobile internet coverage or mobile phone networks. This is going to be achieved through the establishment of a national network of continuously operating reference stations. That's being established in 3 components. First, we're upgrading and modernising or expanding our national geodetic network. We're then licensing data from state and territory CORS networks and incorporating them into the Positioning Australia or MPIC network. And then we're looking at areas where there are gaps and working with private CORS operators to try and fill those gaps. And I'll talk a bit more about that in a second. We're also developing a platform that allows us to verify, optimize, and correct our data streams, and a real-time delivery platform that's able to deliver data to users. And I'll just jump back. The photos at the top here show the construction of one of our geodetic quality GNSS reference stations, and the slide that came up before is a finished product. So this is a station that we operate on King Island in Tasmania, and it was recently upgraded this week. So this is not the most recent photo, but it pretty much looks the same. This is what we refer to as our Tier 1 or Tier 2 infrastructure. So that infrastructure is built to very high standards and supports the development and maintenance of our national reference frames. So you can see the green pillar in the background. That's a concrete pillar anchored to bedrock, moving with the Australian plate so that we know how the Australian continent is moving. On top of that pillar is a high quality geodetic GNSS antenna, and that's connected to 2 receivers in that green cabinet. 2 receivers are used for redundancy and resilience in the systems. We have power systems, generally off the grid solar, with battery backup that will last 5 to 7 days, and a communication system to deliver that data back to our operational data center in Canberra. This site uses 4G communication, but we also use VSAT at various other remote locations around Australia. And this is sort of what one of our typical builds looks like. So the map below shows where we have infrastructure and where we're planning to put infrastructure. So currently there are 130 stations in our network. They're all as part of this program being modernised so that we have a consistent build that allows us to streamline the management and improve operational efficiency. So far, we've upgraded 25 of those stations in the program. This year, we were hoping to have a substantial number upgraded, but due to travel restrictions and COVID-19, that's hampered our plans a little, but we're looking forward to ramping things up in the new year. That network at the end will be about a 200 station network of those geodetic quality reference stations. As I mentioned earlier, we also have third-party stations in our network operated by state and territory governments and private operators, and this is what that sort of infrastructure looks like. It's still really high quality, still quite stable, but it's aimed more at allowing users to connect to the reference frame rather than maintaining and developing the reference frame. So these are slightly lower cost setups, and that's what we refer to as our Tier 3 infrastructure. And looking at what we're doing with the state and territory governments, with New South Wales and Victorian state government and the Queensland state government operate reasonably quite high quality CORS networks. So we've worked with those governments to license data, and that's now, those data streams are now openly available through Geoscience Australia. That's around 350 stations. Queensland will come online shortly because we're still working on some agreements there. What we're also now looking at is where the gaps in the network are, and then working with private operators to establish or access existing infrastructure in those areas. So those key areas at the moment are Queensland, South Australia and Southwest WA. We're not limiting it to those areas. We're happy to accept stations into the network from anywhere across the country, particularly where there's a need. So if you do happen to operate infrastructure, please get in touch with me, and I'm happy to talk to you about how we could potentially incorporate that and open that data up to the wider user groups. Okay. This is a photo of our new operational data center in Canberra. It's here that we monitor the health of the stations, verify, store and disseminate our data streams. That's been online for about a year now. It's currently only staffed 9 to 5, 5 days a week, and we're looking at what the operational model will be in the future at the moment as we start bringing these new capabilities online. And the other component I mentioned was sort of around that processing correction platform to validate and generate coordinates for our stations and our data. We're developing a modern, cutting-edge multi-GNSS software platform, and that platform's got 3 components: a network platform that will generate models of the satellite orbits, the clocks, and the atmosphere, and also generate station coordinates. A combination platform that will help us take those coordinates and generate time series to better understand the movement of the Australian plate and develop our reference frame, and a user platform that we can provide potential users who may not have their own systems to use to access our services and our data and develop use precise positioning information. That software platform will all be open source, and there's various releases over the next 18 months on that. Okay, in terms of accessing our data and services, you can go to our data portal at gnss.ga.gov.au. There you can access our data in real time or static files, see where our stations are, and also upload data and process it online to get an accurate coordinate in the national reference frame in our cloud-based positioning service called AUSCORS. That's kind of it for the Positioning Australia program. I'll quickly flag a couple opportunities. At the moment, GA is collaborating closely with Frontier SI and leading academics to gather further information around how positioning is used across multiple sectors. And we're hoping that information will help us accelerate the adoption of Positioning Australia, ensure that our services, our standards we use, and delivery mechanisms work for the users across different sectors. If you'd like more information about that, you can contact myself or Laurie or Ryan Keenan, whose emails are below there. And I'll just have a quick promotion for the webinar next week that Nicholas Brown, the director of our National Geodesy section, will be presenting. He'll talk about our Australian Geospatial Reference System. That's about that's about it for the presentation today. I'm happy to take some questions if people have any.
Thanks very much, Ryan. It was a very informative presentation. Just a reminder to everybody, if you've got any questions, just type them into the Q&A, or if you would like to talk to Ryan directly, raise your hand and I'll unmute you. Ryan, is there a cost to access the GNSS data streams that you've described today?
No, the idea of the Positioning Australia program was to remove barriers to entry for a lot of these services. The idea was to allow or encourage innovation across the sectors. So all of the offerings from Geoscience Australia are openly available to all.
Okay, and when will the capability be made available?
Yep. So the aim is to have the MP capability fully operational by June 2022. So it's about 18 months away. We're slowly, as I mentioned earlier, upgrading our ground infrastructure network and releasing various aspects of our analysis center software, and together they'll form the capability. So it'll be iteratively rolled out over the next 18 months, and a lot of services are available today.
Yeah, and does that mean that when this is rolled out to everybody, that mobile phones are going to be accurate to centimetre type accuracy?
It's a good question. Technology is currently evolving quickly. To access some of this really high accuracy positioning information, you do require specialist equipment at the moment, but we are working with people like Frontier SI on a number of projects to look at how we can integrate these services into mobile phones. There are a few limiting factors at the moment, particularly battery usage in mobile phones. As you start doing more and more calculations, the battery drains quite quickly. But I think it will come soon. Yeah.
Okay, fantastic. Look, we don't have any other questions, but I think will we be able to make that link to that video available to everybody on the call?
Yep. I can. Probably the easiest way of doing that would be if you go to YouTube and search for Geoscience Australia under our YouTube channel. There's a number of, there's a lot of videos, but there's a number of positioning related videos. One of them is a 101 on positioning, and the other one is the introduction to the Positioning Australia program that didn't play today.
Okay, fantastic. My colleague Anil has got a question for you as well. So Anil, to ask your question of Ryan.
Thanks, Sarah. Ryan, that was a really positive picture painted there in terms of public access to much higher resolution and accuracy data from a positioning point of view. What do you think are the key challenges that need addressing in the medium to long-term future? And then equally, what excites you most about the future?
I caught a bit of that. It was a bit quiet, but you're talking about the challenges in the medium to long term to see these sort of capabilities adopted. Is that correct?
Yeah.
Yep. Yeah. Look, I think the positioning landscape's fast changing at the moment. There's a lot of emerging applications that come from non-spatial areas, so people who aren't used to positioning, and I think it's working with them to ensure that they understand how this data can be ingested and used, and providing things like our analysis center software platform to help them understand that. And I think we're also seeing changes in technology at a rapid rate. A lot of the positioning chipsets and things are becoming a lot cheaper now. A lot of this technology used to be very much for specialist users, but we're seeing the price of a lot of this stuff come down to mass market usage. So it's around recognizing that it'll be more more openly available. I don't know if I really answered that very well, but it's around, I think, challenge for us is improving access and ensuring uptake.
Thanks for that. No, that certainly did. That leads to that. That's a nice segue to the next question I had was, you know, with the future technology that you were talking about, which is rapidly changing, do you think for the resources sector, there'll be a significant change in infrastructure costs for their positioning, mainly based on RTK, as you suggested, in the future, that it will be either available through new constellations, private constellations, enhanced satellite positioning, or other technologies?
Yeah, look, I think all of that to some extent. I think one of the things, you know, you're seeing automation and high levels of assurance in positioning systems in large mine sites, for instance. I think what you'll start seeing is some of these offerings through government delivered services like Positioning Australia, or through open offerings coming through the actual constellations themselves, will allow or enable smaller operations to take advantage of some of the technology that was once you know, closed to them due to cost barriers or other issues.
I've got another question here for you, Ryan, from Chris Marshall at Frontier SI. Where can users find information about the nearest AUSCORS station?
Yeah, Chris, if users go to GNSS at gnss.ga.gov.au, that's our portal. There's a network map there, and that will show you where your nearest base station is. Users who want to access our real-time data streams do need to register with us. On that same portal, there's a link to streams that takes you to our registration page. It's free registration. It really just allows us to understand a bit more about who our users are and see what data streams are being used so that we can tailor our solutions. But it's all free and unrestricted.
Wonderful. Okay, well, look, thanks very much for your time today, Ryan. It was a great presentation. So don't forget, everybody, we have the third webinar next week that Ryan's already spoken about, where Nicholas Brown will be talking about datums and reference frames used for delivering modern positioning services. The week after that, we are running a workshop. Registrations are open for that, and at that workshop we'll be hearing from a number of guest speakers, including Eldar Uganov from Frontier SI, Gareth Dean from Nets Ignited, Julian Kruger from Astron, Nathan Eaton from NGIS, and John Maitland from Roy Hill. We'll also be discussing the challenges and opportunities around positioning. So it'd be great to see you, or as many of you there that can make it. So thank you again, and I will see you next week for the next webinar.